Hey everyone, this is James from the DevGenie Academy, and welcome to the 3D Game Engine tutorial series. In this episode, we're going to be rendering objects or basic shapes to the screen. So without further ado, let's begin. First, in your core package, let's create a new package called Entity. And in that entity, let's create a new class, and we'll call this class Model. The Model class should be pretty straightforward. It's only going to contain two integer values, one of which is a ID, and the second which is a vertex count. And in the constructor, we're just passing those variables in and setting them. So taking an integer of ID and vertex, and we instance them as this.id equals ID and this.vertex count equals vertex count. And the final thing we need to do is just two getters to get both the ID and the vertex count. Next up, we need to create a new class in our core package, which we'll call a object loader. And in this class, we basically need to be tying in values that we're giving to set coordinates of particular objects and also storing them. So we need to create, first of all, two array lists of a VAO, which is a vertex array object, and a VBO, which is a vertex buffer object. So just think of these two values as a list of data coordinate of a object and also the texture coordinates of a object as well. So first, a few methods that we need to do is we need a public model load model, which takes an array, a float array of vertices. We need to then create the VAO from there. And we need to then store data into the attribute list. So that attribute list is the vertex buffer objects. So that will take in as a parameter of an attribute number, a vertex count, and the float of the data as well. And one other method that we need here is an unbind method, which is going to unbind that object from the GLSL. And finally we need a clear up method, which is just going to remove those items from the array. So first of all, we can do that cleanup method by just iterating through the list of the VAOs, and it's just GL delete vertex arrays. And we can copy that for loop and change it to a VBO. And we can get rid of that, and it's GL delete buffers, and again pass through that VBO. In the unbind, it's very straightforward. It's GL30 GL bind vertex array and pass it in a 0 as a parameter. So in the store data in attribute list, we need to first of all get a vertex buffer object, and we can do that by GL15 GL gen buffers. We then add it to our array list, and then we can call GL bind buffers and pass in the parameter of array buffer and the vertex buffer object we've just created. After that, we need a way of actually storing the information in a float buffer. So create an Utils class, and let's create a public static float buffer function called store data in float buffer, and we can pass through the float array of data into this method. So we can create a float buffer, and this is just going to create from a memory util, and it just get the data length. So they can then put the data into the buffer, and then we flip it on its head and then return that back. So back in the store data in attribute list function, we can now call this method. So we can create a float buffer, and we can call utils.store data in float buffer and just pass that array through. Next up, we can then do a GL buffer data function, which takes in a GL array buffer again, the actual buffer, and we also need to say what we're going to be doing with that buffer. So we're going to be just doing a static draw with that. So the next up is we need to do a vertex attribute pointer. So we take in our attribute number, our vertex count, and we need to tell OpenGL what value these are, and we're going to be passing floats. The next three values is just false, 0, and 0. We then need to bind the buffer. So doing that, we just pass again the array buffer. So we pass in 0 as the final parameter. So next up, in our create VAO method, we need to first of all create that ID. So it's GL30 GL vertex arrays. We then add that ID to our VAO. We can then bind the vertex array by passing in the ID as a parameter, and all we need to do now is then just return that ID. So all of these functions together now gives us the ability to load that model. So first of all, we create an integer ID to create the VAO. We store the data in attribute list 0 with 3 vertex counts and the vertices array. We then call unbind, and then we just return a new model, passing in the ID and the vertices.length. Make sure to divide that by 3. And that's all we need to do for the object loader class for now. So back in our render manager class, we can then start populating some of these values in here, because at the moment it's pretty empty. In the renderer, let's pass the model through as a parameter. We then call clear, and then we can call GL30 GLBind vertex array, and we can do that by passing the model.getID. And then we do GL20 GL enable vertex attribute array, and we're going to enable attribute 0. We can then call GL11 GL draw arrays, and we pass in GL triangles because we're drawing in triangles. The second parameter is 0, and we do the model.getVertex count. So GL20 GL bind vertex attribute array 0 again, and then we then bind vertex array to 0 as well, just to unset all of those values. Back in the test game class, let's create a private final object loader of loader, and let's instance that in the constructor of test game at the bottom to make a new object loader. We can then go in our init method, and then we can say float array of vertices. In the vertices, I will be adding in the description below a link where you can download this from, so just paste that in here, and that's a list of vertices, and this is just to create a simple rectangle to the screen. So with that list of vertices, we can then do a private model, because we need to pass that in as the renderer. So we then can say model equals a loader.loadModel, and then pass that vertices as a parameter. And all the way down into our render method, calling renderer.clear, we call renderer.render, and pass the model through as a parameter. And in the cleanup method, we just need to make sure to call loader.cleanup as well. So all being good, we can test that now, and we should see a rectangle rendering to the screen. It may be a black screen, but if you press the up arrow key to change the background from black to white, we can see that the rectangle is indeed there on the screen. So next week we'll be looking at the GLSL shader code, and thanks very much for watching everyone. I hope you enjoyed, and if you do have any questions, please leave them in the comments down below.